are discussing regarding the acidity of phenols. I take phenol. I am comparing it with o-nitrophenol, and we are comparing it with m-nitrophenol, and a comparison is between p-nitrophenol. Now let's start writing what are the things that you can observe here. This is just phenol. I am having the lone pair of electron on the oxygen in phenol. We understood that this is involving in donation of its electron towards the benzene ring, so it is plus M effect. But oxygen is an electron negative group, right? So it will have minus I effect. Now I am going to the next comparison. Definitely we understand there is electron withdrawing group in the other molecules here. This is A, B, C and D. I can surely understand among A, B, C, D, A will be the least acidic because it is not having any electron withdrawing group. It is just phenol here. So it will be least acidic. There is no doubt about it. Now let us compare between these three. Ma'am, nitro group is there. Nitrogen is an electron withdrawing group. Electron withdrawing group will show minus I effect. Okay. Nitro group is an electron withdrawing group which has a tendency to pull the electron towards it. It is also showing minus M effect. Alright. Which position it is? This is ortho-nitrophenol. What about this? This is meta-nitrophenol. At the meta position, mesomeric effect, hyperconjugation effect does not play. And which effect only plays? Only inductive effect is playing. Why mesomeric effect is not applicable at a meta position? Because the electron delocalization led to this electron density, negative charge cloud, which is available only in orthopara position, not at meta position. So therefore here there is no mesomeric effect, but only inductive effect is there. What inductive effect? Minus I effect. Okay. What is this compound? This is para-nitrophenol. In para-nitrophenol, I can say minus I is also there and minus M is also there. Alright. Now ma'am, this fellow is showing only minus I effect. There is no M effect at all. Other places they show both minus I, minus M, both the places are showing. So definitely C will be the next acidic member here. Now, which will be more acidic? A competition really exists between B and D. Now let us brush up what we have learned in GOC. Inductive effect is a distance dependent effect. Inductive effect is a distance dependent effect. That means, ma'am, if it is minus I, that means the electron withdrawing nature is much more high. Correct? If it is very close, the electron withdrawing nature will be very high. If it is little bit far away, the electron withdrawing nature will be less. Same way, if I say plus I, the electron donating nature is going to be higher. I mean, it is very close. Electron donating nature is more. If it is far away, electron donating nature is less. Now, when I compare this ideology in this, ma'am, this nitro group is very close to the phenol here. This is having minus I. Very close. Then it has to be more acidic. Here, this nitro is also showing minus I and minus M. But this nitro group is far away from the OH. So definitely this minus I effect will be less. This minus I effect will be more. As you said, minus I is directly proportional to acidity. So I guess that followed by D and followed by B will be my trend. This is my expectation. Yeah, it is acceptable. Yeah, this nitro is an electron withdrawing group. It is very close, distance dependent. It keeps pulling the electron towards it. Its acidity increases. Definitely. But actually, what is the trend? The real trend: A, C, B, and D. Now, how is this? Why there is a change? It is quite convincible. Nitro is very close, so it has to be higher only. Then why it happened? Now comes a very important game changer here. I have OH and I am having this NO2, right? This hydrogen wanted to go for hydrogen bonding here. If it is going for hydrogen bonding, then how can H plus be released easily? Can you release H plus easily? No. It is involved in hydrogen bonding. Releasing of H plus is only called as acidity. Here the H plus can't be released easily. That's the reason why B becomes less acidic compared to B. Clear? Now children comes for the another question. Okay, ma'am. Then if it can't release H plus at all, how do you say the B is greater than C? Because here the H plus is free enough to get released. There is no hydrogen bonding at all. Then C should be greater than B now. Here we are talking about the probability of forming the hydrogen bonding. It doesn't mean it will definitely form hydrogen bonding. There is a possibility of forming hydrogen bonding. Also, this is at the ortho position. At the ortho position, I can experience a minus M effect here. But here in C, there is no minus M effect at all. Only the minus A effect is there. That's the reason why C is less acidic than D. So this is your real trend. Is it understood for both of you?
Yes, ma'am.
Right? Now let us compare it with NCERT tabular column. Look at the NCERT tabular column, acidic value. Phenol, yes, it is having the highest pKa value, as we mentioned. Higher the pKa, less acidic it is. Yes, okay. Now compare the values here. The next acidic value is here 8.3, isn't it? With respect to pKa value, more is the pKa value, less acidic it is. Ma'am, 10. Then comes 8.3. Yes, it is m-nitrophenol. Then comes ortho-nitrophenol, 7.2. Then comes para-nitrophenol, 7.1. So with respect to acid trend, I can understand phenol is least acidic, followed by meta-nitrophenol, followed by ortho-nitrophenol, followed by para-nitrophenol. Clear? Is it clear for both of you?
Yes, ma'am.